Well, good evening and welcome to Astro Assembly 2022. I'm Scott Tracy and I will be attempting to move things along this evening and tomorrow as we proceed with an event that many of us regard as Astronomer's Christmas, Brian McGaw's words. So I'm really honored to get this kicked off tonight by introducing our speaker, Joe Rayo, who for years has been known regionally as a meteorologist, as well as astronomer. He's worked at Hayden Planetarium and still works at Hayden Planetarium in New York, where he's been for many years. And so we are especially blessed with having him be able to join us tonight. So please help me give Joe a warm Astro Assembly welcome.
Well, thank you very much. Thank you. This is not the first time I've been at Astro Assembly. Actually, I was physically there 31 years ago in 1991, and back then I was only married for 7 years, and we brought our son, who was not quite 1 year old, and after all of these years, my wife is still my BFF, in spite of the fact that last month we were marking our 38th year of wedded bliss. And as far as my son is concerned, he's now teaching physics in a high school not too far from where I'm speaking to you now. I guess science runs in the family. But I'm here tonight. I would have liked to have been with all of you, but at the last minute, my boss at the Hayden Planetarium, Dr. Neil deGrasse Tyson, said, "Hey, we're having a big star fest with telescopes and all kinds of stuff going on in Central Park on October 1st, and I'd really would like to see if we can have you there." And I said, "All right, that'll be fine. I can do my presentation, I guess, via Zoom." Actually, I was scheduled to have two presentations. The one tomorrow, however, on my adventures as an eclipse chaser over the last 50 years, that's been put off until January. So I will be back with Skyscrapers January 7th to deliver my eclipse talk. Tonight, however, I'm going to be delivering a talk kind of involving an eclipse, but a different type of an eclipse. And it's a PowerPoint talk. And so what I'm going to do is I'm going to share my screen right here and go to my, hang on for a second, I go to my slideshow. We'll start from the beginning, and here we go. So all of you fine folks, thank you very much for the invitation to speak with you tonight at the annual Astro Assembly, put on, of course, by Skyscrapers Incorporated. Now, my talk tonight deals with a rather interesting event that's involving a planet, which if you have not looked at lately, you really ought to. It is evident in the sky right around midnight and continues to be evident on toward the early hours of the morning. That planet is the planet Mars. If you haven't seen it yet, when you do see it for the first time, you'll be kind of surprised because Mars is closing in on the Earth, headed for opposition at the end of this year in the month of December, and actually will be closest to the Earth on November the 30th. It is right now shining at a magnitude of negative 0.5. So it rivals just about every star in the sky, save for Sirius and Canopus. We can't see Canopus from our vantage point up here at our latitudes, but Canopus is second only to Sirius in brightness among the naked eye stars. But very soon, Mars is going to pass both Canopus and Sirius, and eventually will become the fourth brightest object in the sky, nighttime sky, next to the Moon, Venus, and Jupiter. And when Mars is in opposition, and oppositions take place of Mars approximately every 2 years and 2 months, that's when is the best time to see the red planet in our sky. Now, all oppositions are not created equal. It turns out that our orbit around the sun brings us closest to the sun not in July or June, but in January. And we are farthest from the sun right around the 4th of July. In contrast, Mars, which also moves in an elliptical orbit, is closest to the sun in August, at least by the standards of our calendar, and is farthest from the sun in February. So when we get into the summertime, and if Mars happens to be, or if the Earth has happened to be passing Mars at that particular point in time, let's say July, August, September, that means that Mars will be making an unusually close approach to the Earth and will shine exceptionally bright. Meanwhile, if we have an opposition occurring, if we pass Mars in our orbit in, let's say, January or February or March, then Mars is rather far from the Earth and is not shining quite so bright and does not loom quite as large in telescopes as it might, let's say, during the summer season. You may remember that not too long ago, 4 years ago, in July of 2018, Mars was situated at opposition 0.38 AU, astronomical units, from the Earth. In other words, in 2018, Mars was only about 35 million miles away. It's shown at a dazzling magnitude of negative 2.7 or 2.8, and it appeared in telescopes as large as 24 arc minutes across. Now, in the years to come, in 2025, 2027, 2029, look at this, Mars will be 0.64 AU in 2025. It's about 59 million miles away. 2027, remember I said that oppositions that occur in January, February, or March are somewhat unfavorable. Well, this opposition occurs in late February of 2027. Mars will be about 64 million miles away from the Earth, about 30 million miles further out in space than it was back in 2018. And so Mars won't even get as bright as Sirius that year. It'll be looming high in our sky, but it won't be any brighter than negative 1.2, and in size, it'll only be about 13 or 14 arc seconds across. And it'll still be rather distant in 2029, in late March, when it'll be about 60 million miles away. So Mars oppositions, again, come every 2 years and 2 months on average, but again, not all Mars oppositions are alike. The one that we're expecting in December, December the 7th, puts Mars at a distance of approximately 51 million miles away. Not terribly close, but not terribly far either. So this really is going to be the last really good opposition of Mars that we will have until, the year 2031. So watch and look while you because Mars will be about as bright and as large in telescopes as it will for another 9 years. Now, here's the moon, and you see it here in its full phase. That's what all the almanacs and all the calendars call it when the disk of the moon is 100% illuminated. But you know what? Really, we could also call this moon at opposition, because when the moon is at full phase, it is at opposition to the sun. When the sun is setting in the west, the moon is rising in the east in full phase. It's highest in the sky at midnight and drops down into the western sky as the sun is coming up in the east the following morning. In this particular diagram, you can see, here's the Earth. When the moon is at new phase, we're looking more or less toward the sun. You can see the rays of the sun coming down from this direction. Then, of course, there's first quarter. And at full phase, well, from our vantage point, the moon is opposite to the sun in the sky and is completely, and the disk is completely illuminated, and so we have a full moon. Now, what is interesting about this upcoming opposition of Mars is the fact that we are going to have a most unusual alignment, or if you will, a syzygy. We're not going to have 3, but we're going to have 4 celestial bodies lining up almost in a perfect straight line on the night of December the 7th. Here's the sun, here's the Earth, here's the moon, and here is Mars. Now, having this alignment, the moon and Mars are going to be at opposition within literally just minutes of each other. on the overnight hours of December 7th and 8th, the moon is going to be reaching full phase at 11:08 p.m. Eastern Standard Time. So, at that moment, the moon will be in the sky 180 degrees from the sun. Of course, the sun will be below the horizon at that time, but in terms of celestial longitude, there you have it. The moon is going to be directly opposite the sun as seen from here on the Earth. But look at this. Look at this now. Mars will also be directly opposite to the sun in the sky as seen from our vantage point here on the Earth, and that will occur at 12:35 a.m. Eastern Standard Time during the early morning hours of December the 8th. So the difference between the moment when the moon is full and the moment when Mars is at opposition, the difference is only 87 minutes. And I did some research using some planetarium software, Starry Night Pro, Dance of the Planets, Stellarium, which many of you I'm sure are aware of and probably have worked with at one time or another. And I can tell you this, in the last going back 300 years and going forward 300 years, we don't have a case anywhere near this in the past or the future where the moon arrives at full phase at almost the same time that Mars is at opposition. Again, only 87-minute difference. And again, almost a perfect alignment in space on that night of December 7th and 8th. And as an artifact of the exceedingly close occurrence of Mars at opposition to the sun and the moon at opposition to the sun, because of that, what we're going to have occurring on that night is an occultation. The moon is going to pass in front of the planet Mars and eclipse it, as seen from, well, a rather wide area of the United States. In fact, everybody who is located to the north and west of this yellow line that you see here, everybody up here and out here, all of this part of the U.S. will see the moon cover Mars for, well, it depends. If you're near the occultation southern limit right here, it'll be for maybe just a few minutes. But if you're, out here in Seattle or Portland or up in southern Canada, Mars will be behind the moon for upwards to an hour or more. Now, that's for folks who live on this side, the left-hand side of this line. How about the folks who live on the other side of the line? Well, it's going to be a near miss. And as you can see, in Providence, Rhode Island, in Boston, Cape Cod, and most of southern New England, and in New York City, it's going to be a near miss. In other words, there will not be an occultation, but the moon is going to come very close to Mars or vice versa. Now, interestingly, when you saw that line that separates the occultation zone from the non-occultation zone, when we're dealing with an occultation of a star, that line, generally speaking, is measured only in a few hundreds of yards. What you're seeing here is the path of the southern limit of an occultation that took place, the northern limit of an occultation that took place of Antares, the bright red star in the constellation of Scorpius the Scorpion. This was back in 1968. And you see the line here. This is the line, the northern limit of the occultation zone. In other words, everybody who lived above this line would see a near miss of the moon passing over Antares. Antares would always be visible. South of this line, an occultation would take place. And look at the line here. Again, this line, this path, is only going to measure in width maybe a few hundred yards. And indeed, in this particular case, look at this. The path of this occultation, the graze line or limit, if you will, passed over lower Manhattan and portions of Brooklyn and Queens and a little part of Long Island before going out into the Atlantic Ocean. So folks in Brooklyn, for example, and Staten Island, they would have seen, for a few minutes at least, the moon cover Antares. But for people who lived in the Bronx, and I was in the Bronx back in 1968, that was not going to be evident. That's going to be a very close miss. And the reason why this line, this graze path, is so thin, so narrow. I mean, if you were on this graze path or within a few hundred yards of the center of this graze path, you would have seen Antares go in and out and in and out and in and out between valleys and mountains on the edge of the moon. That's what would have been visible. But the reason why it is such a narrow path of measuring only in yards is that what we're dealing with is a star. If you've never, when you look through your telescope, looking at any of the brightest stars in the sky, Antares, Arcturus, Vega, Spica, these are little pinpoints of light. No matter how much power or magnification you apply in your telescope, you're always going to see nothing more than a dot, a pinpoint, a speck of light. And that's why when the moon covers a star, if you're near one of the limit points, the northern or southern limit, that limit is only going to be measured in 200, 300, 400 yards. And unless you happen to have a very accurate map, and unless you happen to be right on or very close to that line, you're either going to see a very near miss, or you're going to see the moon actually cover the star for a few minutes. People try to get to the graze line because they want to see that sight of the star going, again, in and out through mountains and valleys and crevices along the rough edge or rough limb of the moon. Now, in the case of what we're going to have happen on late on the night of December the 7th, that's not going to be the case. When we're dealing with the occultation of Mars, we're going to be dealing not with a very narrow zone measuring only a few hundred yards wide. We're going to be dealing with an actual path, a path that's going to be roughly 21 miles wide. So the limit, the graze limit, the southern limit of the occultation is going to run 21 miles wide across this zone, across West Virginia, almost cutting diagonally the state of Pennsylvania, and then on up into lower New York State. And since I'm talking to a New England group here, here's what it's going to be relative to southern New England. So this path, again, around 21 miles wide, located within that path is Northampton and Amherst, Fitchburg and Leominster, Lawrence and Haverhill, Boston. Well, Boston's out of it, but you can almost walk to the southern limit of this zone. Now, the question is, if you're in that zone on occultation night, what are you going to see? Well, that's an interesting question. You see, the reason why it's 21 miles wide is that Mars in your telescope that night will not be like a star. It will not be like a tiny little pinpoint of light. What it will appear to be will be a disk, a sizable disk, about 17.5 arc seconds across. Not very big as compared to, let's say, Jupiter, but for Mars, that is pretty darn big. The biggest that Mars can appear in a telescope from here on the Earth is about 25 arc seconds across. And this upcoming opposition, again, not the best, but not the worst. It's kind of like a modest or a median opposition where it'll be of some size. But in any case, the fact that we're looking at something that's 17.5 arc seconds across means that when that limb of the moon arrives at the disk of Mars and starts covering it, Mars is not going to do what a star does. When you're looking at an occultation of a star, you watch as the moon approaches closer and closer to the star, and then when the edge of the moon reaches the star, boom, blinks out, almost as if somebody threw a switch, and almost instantaneous, it just pops off. It's especially dramatic when you see the star either disappear or reappear along the dark side of or unilluminated side of the moon. That doesn't happen in this case with Mars. If you're even in the total occultation zone, it's going to take almost a full minute for Mars to disappear behind the edge of the moon, because it's going to take that long for the moon, moving in its orbit around the Earth, to first touch the disk of Mars and then gradually, slowly cover up the rest of the disk of the planet. So now, if you are within this zone here, the southern limit of the occultation, let's say, for example, that you were stationed in Lowell, Massachusetts, what would you see? You would see the moon interact with Mars, but much of the disk of Mars will remain in view. Only a part of it, a small scallop of Mars, will be covered by the moon. And then most likely, what you're going to see is the planet Mars interact with, mountains and valleys on the moon. So, you'll see some of it disappear, but much of it will remain outside of outside and not being occulted by the moon. However, let's say you decided, no, I don't want to go to Lowell to watch the occultation. I think I'm going to go up to Deary. What would you see up there? Well, in Deary, you're very close to the limit of a total occultation. So in Deary, what you're going to see is most of Mars covered by the moon. Only a small sliver of Mars should remain in view, triumphantly remaining in view, while the moon slowly slides by the planet. And if you're right in the middle of the path of this or of this zone, what you're going to see is part of Mars, half of Mars covered, and the other half remaining completely in view. In fact, this pretty much is what you would see if you were, let's say, in Deary. Remember, I just mentioned to you about what you would see from various parts of in Deary, where they're almost going to be a total occultation, but not quite. They're still in that partial occultation zone. You'll see the planet go behind the moon. A little bit of Mars will still remain in view, and then as the moon continues to move by, more and more of Mars will become uncovered. This photograph was taken during an occultation that occurred in July of 2003, the year of the Great Opposition. You remember back in 2003, that was the opposition where Mars came closest to the Earth, the closest it had been in about 60,000 years. That would be in late August. This was July, and they saw this occultation by a waning gibbous moon. See, here's the bright side of the moon, and this was the dark side. Now, unfortunately, in December, I'm talking about a full moon. So the entire disk of the moon is going to be illuminated by the sun. So you won't be able to see Mars disappear or reappear behind any of the dark side of the moon because, again, 100% of the moon will be in sunlight. But still, you get an idea if you happen to be positioned inside of that 21-mile zone of partial occultation, what you would be able to see. Now, I'm not sure whether or not your tastes are, to see a partial occultation, to see something like this. That doesn't come along every day or every night, so you might want to position yourself in the zone of partial occultation, or maybe you want to go even further north of Lowell and into the zone where the moon will completely hide Mars for maybe several minutes before it begins to emerge again. But what happens to the folks who live in Boston, in Providence, in New York, places that are not going to see an occultation? How close is the difference between the limb of the moon and Mars? Well, as Maxwell Smart was explaining to the chief of control some years ago in a similar situation, well, Chief, it's going to be missed by that much. Here's an example of what other cities will see that will not see an occultation. Washington, D.C., the occultation or the near occultation, actually no occultation whatsoever, but the closest that the lower edge of the moon, the southern rim of the moon will come to Mars will be 10:46 p.m. that night, and the difference between the limb of the moon and Mars will amount to 1.7 arc minutes. In Baltimore, or if you're a native of that city, in Baltimore, 10:47, 1.5 arc minutes difference. Philadelphia, 10:51 will be the closest approach of the moon to Mars, 1.4 arc minutes. New York, the Big Apple, 10:56 p.m., 1.1 arc minutes will separate the lower limb of the moon to the planet Mars. And you say to yourself, well, Joe, come on now. If the Mars is that close to the moon, will I even be able to see it with the naked eye? Well, actually, you will, because you may have noticed at times when there's a full moon, let's say near a star like Regulus or Spica, you say to yourself, my God, I can hardly see it because the moon is so brilliant, it almost completely squelches out the light of even a first magnitude star. And I've even seen Saturn at times very close to the full moon or nearly full moon, and that's like 0 magnitude. But I can assure you that you will be able to see Mars even when it's practically touching the moon's disk with the naked eye, because Mars on that night will be just shy, a trifle fainter than -2 magnitude. That is very, very bright. And you will be able to see it. And in fact, when Mars is closest to the moon, it will look like an amber colored speck or jewel of light hanging off the bottom of the moon's disk. So you will be able to see it. It'll, of course, be even more evident if you're using binoculars, and it will be especially interesting to watch if, again, you don't plan to get into the occultation zone, to see the disk of Mars come oh so close to the southern edge of the moon. Hartford, 10:59, closest approach, only 0.6 arc minutes away from the lower limb of the moon. Providence, 0.9 at 11 o'clock, straight up. And Boston, 11:01 p.m., they too, like Hartford, 0.6 arc minutes away. And if you want to get an idea or gauge just how large 1 arc minute happens to be, well, here you go. Mars, the width of Mars, the apparent size of Mars, will be 17.5 arc seconds across. So basically, Mars will be, when it's only 1 arc minute from the limb of the moon, Mars will be approximately 3.5 Mars diameters from the edge of the moon. So that would be for 1 arc minute. And if you're in Boston, let's say, Mars will be right about here, very, very close, practically touching. And if you're just outside the limit of the path of the partial occultation, it'll appear as if Mars is, again, practically touching the limb of the moon. Now, you may, I'm sure that a lot of you, all of you, will probably alert your friends and families and neighbors, and probably you, unless you, if you plan to stay at home for this and not go into the occultation zone, set your telescope up in front of your house, and I'm sure you'll, tell all your neighbors, hey, come on outside and take a look at this. This is going to be really special. It's going to be a tight conjunction. Well, you could call it that. You could call it a tight conjunction, but really, in this particular special case, the word that you should be using is a pulse. And in astronomy, that is the apparent very near approach of one celestial body to another, a coming into conjunction. Now, I would say, while there's not an official definition as to how close a celestial body needs to be next to the moon, I would say let's limit it to 1 arc minute, or maybe let's limit it to 6 arc minutes. That's a little bit better. 6 arc minutes. Anything closer than that would be an pulse. You may remember 2 years ago, Jupiter and Saturn were in conjunction in December of 2020. A lot of the news media people called that the Great Conjunction. Well, you could call it that, but you could also just as well call it a pulse between Jupiter and Saturn. Rather unusual to see 2 planets coming as close as 6 arc minutes. Even more unusual to see a planet, a bright planet like Mars, coming less than 6 arc minutes to relative to the moon's limb. But that's what we will have on December the 7th if you don't care to travel into the occultation zone. And of course, if you do go into the occultation zone, the next question that will obviously be asked will be, well, how often does this happen? Does this happen very often? Mars getting covered by the moon? An eclipse of Mars? How often does that occur? Well, to answer that question, why don't we go back a ways? What you're seeing here on the screen is a view taken from the 86th floor observation deck of the Empire State Building back in July of 1974 when there was an occultation of the planet Venus. Oh, I was on that 86th floor observation deck that morning with our local astronomy club here in New York, the Amateur Observer Society. See, back then, back in the day, we made an arrangement with the Empire State Building, the club did, to go up on top of the observation deck whenever there was a very special astronomical event taking place. The Empire State Building said, yeah, that sounds great. We'll open the doors for you and your members. And this was not just during the evening hours, 7, 8, 9 o'clock. We could go up there anytime. And so when we alerted the Empire State Management that there was going to be a rare event, the moon passing in front of Venus in 1974 July, and my God, I think about this now. This was I had just graduated from high school a few weeks earlier, so this goes way back. I tell this to kids, and they look at me like I came from the Stone Ages, 1974. But 1974, we did have an occultation of Venus as seen from New York, and then the next day, and I often say to myself, why the next day? Why didn't they have an article about it the day before the occultation to promote it, to tell everybody to get up early and to take a look at this wonderful sight in the eastern sky before sunrise? No, they only had an article about it the day after. The New York Times had an article the day after the occultation. Moon is a co-star with planet Venus in a celestial show. Now, the article started out really well, a bright light suddenly appearing in the black sky above the bowl of a crescent moon. But the next paragraph is troubling. It is troubling to me. It says, while newspaper and radio stations received inquiries about the light, and I'm sure, by the way, that most of those inquiries were, hey, I see a UFO next to the moon. Look at that big thing. What is that? Well, actually, of course, it was Venus. It was Venus. But the second paragraph here said, amateur and professional astronomers in New York were delighting in a rare occultation of the bright planet Venus by the moon, the first one visible in this area in modern times. In modern times? I didn't see this. I have to confess, I did not see this article in the Times until many, many years later. I was doing some research on occultations. I stumbled across this article, read the article, and I just shook my head in disbelief, because later in the article it says, although the frequency of the phenomenon has not been calculated, it is believed to be as rare an event to be visible from a given spot on the Earth as is a total eclipse of the sun. On the average, solar eclipses are visible from any one point every 360 years. And the article continued to say that this occultation, which occurred in July of 1974, probably was the first time this had happened from New York in about 300 years. And I said, that's wrong. And I knew it was wrong. You know how I knew it was wrong? Here's how I knew it was wrong. Number one, and I'm sure many of you have read, I hope many of you have read this book, Starlight Nights, The Adventure of a Stargazer, the autobiography of probably the greatest amateur astronomer who ever lived, Leslie Peltier. And in this book, Peltier writes about seeing an occultation of Venus from his home in Delphos, Ohio, in January of 1923. And that occultation, by the way, was not only visible from Delphos, Ohio, but from New York. So right there, immediately, I can point to an occultation that occurred in the 20th century, about 50 years earlier from 1974, but there was another occultation in 1923 from, again, the New York area and from much of the Northeast U.S. And then another great book, which some of you may have read and may even still have, New Handbook of the Heavens. And here is a picture taken by one of the authors of that book, Dr. U.S. Rice, who was a member also of the Hayden Planetarium, of an occultation. This was the planet Venus emerging from behind the dark limb of the moon after an occultation And the photograph was taken without using any type of mounting or telescope, directly from a roof of a building in New York. I later was able to find it in 1937. So wait a minute. This occultation, according to the New York Times, of Venus doesn't take place from any one spot on Earth for 300 years or so. And yet I found one in 1923, another in 1937. Then there was that one in 1974, which I saw. And guess what? 4 years later, not 300 years later, but just 4 years after the occultation from New York in 1974, maybe a few of you old timers remember this, on the morning after Christmas, December 26, 1978, another occultation of Venus, visible throughout much of the United States. And this was a spectacular sight. I saw this from the roof of the building where I was working. I was working for a private weather service, and I actually was live on the air. I was watching this event, and I was doing radio stations. There was this service that provided syndicated weathercasts throughout the northeastern United States, and I was on with a number of radio stations urging people, get up, take a look. This is a wonderful sight. The moon is passing in front of the brightest planet, Venus, and it was spectacular. But the bottom line of it is that what the New York Times had said back in 1974, that this only happens, on the same frequency as a total eclipse of the sun from any one spot on Earth, was wrong, was absolutely wrong. And I had mentioned this on an electronic internet site, the SEML, the Solar Eclipse Mailing List, in 2010. I don't know exactly why I was talking about an occultation of Venus on a solar eclipse mailing site. Maybe it was because I was talking about the frequency, according to the New York Times. But I said, isn't this something? They said that this, and I said, I know for a fact that an occultation of Venus probably occurs a lot more frequently than what was quoted in the New York Times. Well, the next day, after my message was posted on that internet board, the next day I heard from this gentleman. This gentleman is probably, at least in astronomy, the closest thing to an Einstein that we have. He's 93 years old. His mind is still as sharp as a tack, and his name is Jean Meus, and he is from Belgium. Interestingly, like yours truly, he is a retired meteorologist, although a lot older than me, but also he was very interested in astronomical calculations. Maybe some of you have purchased his 5-volume set, Mathematical Astronomy Morsels, where he does all kinds of arcane calculations involving the sun and the planets. He has published a book called Astronomical Tables of the Sun, Moon, and Planets. And back in 1966, he published a book called Canon of Solar Eclipses, which gives all the information about solar eclipses for hundreds of years in the past and hundreds of years in the future. And so you can calculate eclipses using that book. This is an amazing guy. And the day after I had pointed out that about that erroneous New York Times comment, he contacted me and he said, are you sure that the newspaper actually said this? And I sent him a copy of the newspaper article. And when he read it, he got back to me and said, this is terrible. This is terrible. He said, something must be done. Can you write to the newspaper and point out their error? And I said, well, Mr. Meus, that may be all well and good if it was in 1974. Made sense if I had written that letter a few days after the Venus occultation in 74. It doesn't seem to make much sense now if I lambaste the New York Times 35 plus years later and say, back in 1974, you had an article and you no, it wouldn't work. So then he made an incredible offer to me. He said, would you be interested in co-writing a paper on this? We could discuss this about the frequency of occultations of the planet Venus. Now, this blew me away. I mean, this man is a master scientist. He is known all over the world. He is highly respected. Now, here he is asking little old me to join him and ask that we co-write together a paper or an article about occultations and how the frequency of occultations of Venus. Well, of course, I said, yes, of course. And so over the course of the next year, we exchanged notes and made comments and everything else. And in February of 2011, sure enough, in the bulletin of the Journal of the British Astronomical Association, here is an article co-written by Jean Mayus and Joe Rayo, Nocturnal Occultations of Venus. And what we did was we took into account, because you can have occultations of Venus or any planet during the daytime. What fun is that? We only considered nighttime occultations, and what we did basically was we looked at a dozen cities all around the world. You can see them here: Reykjavik, Moscow, Greenwich in England, New York, Tokyo, Los Angeles, Miami, Honolulu, Dakar, Senegal, Quito, Ecuador, Cape Town, South Africa, and Dunedin in New Zealand. We looked at all of these cities, did separate calculations of how often Venus occultations at night occur, and then what we did was we exchanged notes and everything else, and we came up with a frequency, an average frequency of when you might expect to see from a given spot on Earth an occultation in the nighttime hours, or when the sun is below the horizon, of the planet Venus. And I also, just recently, for an article that's going to appear, by the way, in the December Sky and Telescope, we'll have an article about this particular upcoming Mars occultation. I went through the same methodology that Jean Mayus and I did for Venus, and did the same thing for Mars. Nocturnal or nighttime occultations, average frequency. Well, for the planet Venus, it certainly is not 300 plus years. On average, we have occultations of Venus from a given spot on Earth, nighttime occultations, 31 years. And you might be interested to know that in only 9 years, in September of 2031, we are going to have an occultation of Venus in the pre-dawn skies, visible from right here in the northeastern part of the United States. So you'll be able to see in southern New England. I'll be able to see here in New York. Naturally, of course, it'll be cloudy that morning, but nonetheless, Venus will be occulted by the moon. It'll be the first time we have an occultation since that day after Christmas occultation of Venus in 1978. Again, I went through the same methodology that we went through for Venus for the planet Mars, and found that for Mars, the average frequency of an occultation at night is 14 years. It's about half the average time for Mars versus Venus. And you say to yourself, well, why is that? Well, think about it for a moment. For Venus, Venus can never get any farther from the sun in our sky than 47 degrees. It's an inferior planet inside of the Earth's orbit. And so only when Venus is as far as 47 degrees or less can you somehow get the moon to pass in front of it. And the moon always has to be a crescent. You can never have a full moon covering Venus. It just wouldn't work. So a crescent moon, either waxing or waning, and within a little less than 4 days of new phase. And so when you come down to that, you see that the occultation of Venus only occurs on average of once every 31 years. Now, for Mars, it's a whole different case. Mars can be anywhere in the sky. Mars can be opposite to the sun, as we will have in December. Mars can be very close to the sun, and in which case, when Mars is near to the sun, let's say nearing conjunction or just coming out of conjunction, you'd have a crescent moon. Also, at that time, Mars is very dim, only second magnitude. But when Mars is in opposition, for example, then it can be very bright. In this case, coming up, -2 magnitude, rivaling Sirius in brightness, but also being occulted by not a crescent moon, but by a nearly full moon, a gibbous moon or a full moon. And that's what we have coming our way in December. So the frequency of Mars being occulted by the moon averages about once every 14 years. So you could tell your friends in December that Mars gets covered by the moon on average for a given spot on the Earth about once every 14 years. And if it happens that it's cloudy on that night, which might very well be, I mean, whenever we look forward to a very special event, it always seems that way, doesn't it? But if it is cloudy and your friends say, oh, I guess I'm going to have to wait now 14 years from now, what is that? That's the year 2036. You could tell them, no, you won't have to wait. Remember, 14 years for Mars frequency occultation is just an average. It turns out that the next widely visible occultation of Mars, and this will be visible throughout all of North America, will come on Monday, January 13th, 2025. And just like the one coming up in December, it will again come our way at about 11 o'clock in the evening, Eastern Standard Time. And oh, incidentally, Mars will be in opposition, not within a few minutes of full phase. Mars comes to opposition 2 nights later on January 15th, which means that we won't have a full moon covering Mars in 2025, but we'll have a waning gibbous moon, probably about 97 or 98% illuminated by sunlight. And that again is in January of 2025. So again, more details on this will be available to you if you subscribe to Sky and Telescope or want to pick up a copy at your local newsstand. There will be a major article by myself and Bob King, who edits the Celestial Calendar section of Sky and Tel, in the December issue coming up. And again, after December, we'll have our next shot at seeing this rather unusual sight in 2025. However, the one thing that 2025 will lack is that the southern limit of this occultation is going to be way, way down here, past Central America and in northern South America. So you will not be able to see a grazing or partial occultation as you will this coming December. What you will have will be a total occultation, probably lasting about an hour or so on that particular night. And on that night, since it's a waning gibbous moon, what will happen will be that you'll be able to see Mars disappear behind the dark sliver or dark edge of the moon, and then reappear on the bright side of the moon about an hour later. That'll be again in 2025. So that's it. That's the unusual astronomical occurrence that's coming our way in December. So now that you are aware of it, you might want to mentally think about this for a while and consider whether or not you want to see either a very, very close pass of the moon relative to Mars or an appulse in December, or whether or not you want to jump in your respective cars and travel north a little ways. For me, it would probably be about a 45-minute drive from where I am up into the partial occultation zone, and probably about the same for all of you to see this event as a partial occultation. And if you want to really see a total occultation, again, you have to go much, much further to the north beyond that graze limit or that graze path to see the full moon pass completely in front of Mars in December. So anyway, that's it. I've been blithering to you for about 45 minutes or so I'm now going to unblither, and if you have any questions, I'll be very happy to answer them. Thank you.
You entertain a few questions, Joe?
I'd be very happy to.
Do we have any questions? Yes.
I do. My question relates to the graze. You, of course, talk about stellar occultations, and we're all familiar with in, out, in, out, in, out. Those of us that perhaps have done some graze observation. When Mars passes in a graze behind the moon, if you used a very high magnification on your telescope, would you be able to see any silhouette, any profiles of the hills and the craters on the moon against the background of the red planet?
If this were an occultation which involved the dark limb of the moon, that would be a heck of a lot easier to see. We're going to be dealing with a very bright full moon. I suspect that you will be able to take note of the rugged, rough edge of the moon interacting with Mars. I'm not quite sure whether or not it will be easy to, I mean, I know that it's not going to be a case of a smooth limb that's interacting with Mars, you probably will be able to notice some mountains, or maybe the rough terrain of the moon interacting with Mars. Again, but it's not as dramatic as you just noted with a star. With a star, once the star moves behind, let's say, a mountain, it's going to blink out, and then it will blink back on again. In the graze or partial occultation zone, you probably will be able to notice the rough edge of the moon against the disk of Mars, but it's not going to be necessarily a situation of Mars going in and out, because, again, in the partial occultation zone, it will, at least a part of it, will always be visible, will always be evident to you. So it'll be a bit different than seeing it compared to a graze of a star, but it still should be interesting. I mean, like I said before, this doesn't happen every night of the year. And in fact, I have been watching the sky for the better part of the last 50 years. Oh, don't want to think about that. And I did travel back in 1985 to see a grazing occultation of Mars down in central New Jersey, or New Jersey. And it was different than what we're going to see in December. Number one, it involved a crescent moon. Number two, Mars was much dimmer. It was about 1.5 plus 1.5 magnitude, and the disk of Mars was much smaller. And in fact, we did see a couple of times Mars actually go in and out behind a mountain because of its much smaller size, as opposed to the size that it will have in December. So it's going to be different than a stellar occultation, but still something, I think, which is rather unusual, and something that who knows when you're going to get another chance to see something like that again.
Anyone else? Just a quick question for me. Are there any, well, there's not much atmosphere on Mars, but any atmospheric related effects we might keep an eye out for?
I'm not sure. In fact, David Dunham, who is the Mr. Occultation, if you will. I guess if Fred Espenak is Mr. Eclipse, David Dunham is Mr. Occultation. And I know that 50 years or 75 years ago, an occultation like this would have been very important in terms of, maybe charting the lunar limb. I'm not sure if the occultations today are as important as they were, 50 years ago, when there used to be expeditions who used to position themselves along or near the graze limit of the occultation. So I really don't know how to answer your question, except to say that, there is some science involved, I'm sure, that people are still interested in looking at and watching it. But again, it's not quite as important, or stands as quite as important as it might have, let's say, 25 or 50 or 75 years ago. And I would suspect that an occultation of a star, in terms of lunar limb information or determining the topography of Mars, the topography of the moon, is probably more important or more interesting with a star, as opposed to something with a sizable disk such as what Mars is going to present to us on the night of December 7th.
I'll go in the back.
Yes. Has there ever been anything like an occultation, or will there ever be an occultation of planets like Jupiter coming in front of Saturn, for example? The possibility of that happening?
Well, with Jupiter, of course, or even with Saturn, I have seen, by the way, occultations of an occultation of Saturn, and I've seen a couple of those. There is probably no more a dramatic occultation than if you were to watch Saturn emerge from behind the dark limb of the moon. I saw that back in 1973, and it was absolutely stunning to watch first the edge of the ring beginning to appear, and then after that, seeing the disk of Saturn, and then see the back edge of the ring coming out from behind the dark edge or dark limb of the moon. And Jupiter, I've not seen an occultation of Jupiter. We had a chance back in December of, I think, 2006 or 2007. We had an opportunity to see an occultation of Jupiter. That would have been stunning, except, of course, it was cloudy that morning. But not just Jupiter, of course, but also you have the moons of Jupiter. you'd be able to watch one of the moons popping out first, and then in the second, and then the disk of Jupiter, and maybe a third and fourth moon coming out. I don't know off the top of my head when the next Jupiter occultation will be visible from our area, but that certainly would be something that would be most interesting to see. I'll tell you also, in February, I think, of 1991, I saw the most amazing stellar occultation, and that is of Antares. Now, many of you may be aware, Antares is a double star. Antares is a supergiant red star, but also right next to Antares is a very small greenish-white companion. But you can't see the greenish-white companion because it's too close to Antares and is lost in the glare of Antares. But when you have an occultation of Antares, where you're able to see the emergence of the star on the dark limb of the moon, and I saw this in February of 1991. This blew me out of the water. Is the fact that I'm waiting and waiting and waiting for Antares to reappear, and then all of a sudden, out pops this star, and I said, "Gee, that's Antares. It doesn't look overly bright. It doesn't look very, it looks so dim." And all of a sudden, like 5 seconds later, boom! Out came Antares, and I realized later on what I had seen. I had seen the companion, and it took 5 seconds before the moon uncovered Antares. They're that close together. So the only time really you can see that companion of Antares is during an occultation. I've looked into the future, and I'm sorry to tell you that the occultations of Antares we're going to have in the coming years ahead, the next 10 years or so, all involve the moon and Antares going behind the dark side of the moon, disappearing behind the dark side of the moon, and not the emergence from behind the dark part of the moon. When it goes behind the dark limb of the moon, going into the moon, you can't see the companion, because the companion leads Antares out when it's being uncovered. You can't see the companion when it's first to go in. So I don't know when I'm going to get another chance. That might have been my only chance in 1991 to actually see something like that. But it was an amazing sight to see. The chance to see the companion of Antares, only again when you have an occultation of Antares occurring with the star reappearing on the dark limb of the moon, and that was in February. So that was I had to get up in the morning, like 4 or 5 a.m. to see that in the morning sky. But it was really one of the, if I had not seen the great solar eclipse that year from Hawaii in 1991, if I hadn't witnessed that, then 1991 to me would be remembered for that occultation of Antares, because that was really an amazing sight to see.
Anyone else? I'd just like to put in a plug for I'm sorry. Go ahead, Marion.
Oh, that's okay. I just wanted to mention that I can well remember one of the Saturn occultations, because it was the day before 9/11. It was in the morning around 9:30, and I guess it's September 10th. It was a beautiful, clear morning.
That's
and
right.
I thought that's such a great occasion, and then having the next day happen.
Can I tell you a true story? And I tell you this, and I swear to you that this is the absolute truth. I had told you that back in the 1970s, the Amateur Observer Society had struck a deal with the Empire State Building to allow us to go up on the 86th floor to see special events like lunar and solar eclipses or occultations of Venus. I saw a transit of Mercury from the observation deck of the Empire State Building in 1973. That occultation of Saturn that you mentioned, the day before 9/11, the AOS had approached the World Trade Center a while back before that, telling them about that occultation and saying, hey, could we possibly go up on the World Trade Center and observe that occultation on the 110th floor? And the World Trade Center was not as kind-hearted as the Empire State Building, and they said no. But in a way, now I'm thankful. Even though it was the day before, who knows? If the terrorists had decided that they would go on the 10th instead of the 11th, and a bunch of us were up there observing Saturn and that occultation, who knows? You know, it makes you, it's something that makes you think. So.
All right, I just wanted to say in defense of the daylight occultation of Venus, I can't remember which year, it was back in the 90, 91, maybe 92. There was a daylight occultation of Venus. I can't remember which time of day, I believe it was before noon. Sun was high in the sky, and to find the moon, it was a bit of a challenge.
Yeah.
When the moon was established, of course, you could look it up in the ephemeris and figure out how many degrees it was from the sun, and then use your telescope setting circles to find it. But the moon was either a waning gibbous or a waning crescent high in the sky. And Venus was very close to it, of course, in the same phase. So you watch it disappear, but what do you see in the reappearance when those two horns of Venus first? Now you can't see the dark limb of the moon in the day, of course.
Right.
So you're hoping your telescope is on a lunar tracking, so the moon part you want to see is still in there when this happens. And looking the eyepiece, I remember when Venus reappeared, you saw two dots.
Right.
And the
Absolutely.
two dots got longer and longer and longer, and then joined to form the crescent, and then Venus came out. And
Interesting. In the
really unforgettable. I'm sorry?
in the 1974 occultation, that occultation, Venus was just either a very small full phase or a very small gibbous phase. But the occultation that took place the morning after Christmas in 1978, Venus was a crescent, and it was not too far away, I think, from greatest illuminated extent or greatest brilliancy. It was a crescent, so we were actually able to see a crescent Venus being occulted by a crescent moon, and that was a marvelous sight to see if you were using, let's say, a low power telescope, 30 or 40 power, to see both the crescent of the moon and the crescent of Venus. Sights that, again, remain ingrained in your memory for the rest of your life.
Yes.
And it's really an unusual and amazing sight.
Just quickly, one other on the form of occultation. At about the same time, a few years earlier, Saturn occulted 28 Sagittarii. I believe it was about a 6th or 7th magnitude star. And the fun one there was, as the rings passed in front of the star, you could see the starlight clearly shining through the rings, winking on and off as chunks went by to occult the star. And then it stayed bright during Cassini's division, and then this jumping on and off again as the debris of the rings occulted it. And then the whole thing happened in reverse on the other side. So
I remember that as well, and that too was very interesting, because within a few years of that, we of course had Shoemaker-Levy crash into Jupiter, and so you had a chance to see Jupiter looking like it had two black eyes, for example. I mean, amazing to see things that happen so close together. I'm still waiting for that supernova. I'm still waiting for a repeat of Cassiopeia Tycho star. We haven't had one of those in a long, long time, or another chance to see possibly a brilliant comet like a Hale-Bopp or Comet West. You wait a long time, and then when they finally do happen, you take full advantage of them, because the sky is the limit, and you take, whenever something unusual happens, you make sure that you're out there with your telescope and observe it. And this event coming up in December, well, like I said, don't happen too often. Hopefully it'll be clear, and hopefully we'll get a chance to see it. A few years ago, an asteroid was going to cover Regulus, and the path for that. And so when the asteroid, which was like 11th magnitude, was passing in front of Regulus, to me, naked eye, looking up, Regulus would have suddenly popped off or disappeared for about 8 seconds. I mean, what an incredible thing to see, right? And as it turned out, according to the path that was put out by David Dunham, that path passed right over my driveway. Right, I mean, literally right over my driveway. And as soon as I saw that, I just threw up my arms and said, forget about it. Forget about it. I ain't going to see this. No way in the world is it going to be clear that night. And you know what? I was right.
Fatalist.
Mr. Yes,
We have to be a
Mr.
fatalist to do astronomy in New England, so.
Exactly, Mr. Negativity. When I see something, when I see an event, when it's clear and I do see it, I'm as shocked and as surprised as the next person. So I go in, and I have never, for example, I don't know how many of you have been to Cherry Springs. I have never been to Cherry Springs in my life, and many people I know have been there. Said, Joe, you got to go see the sky and everything else. And I said, no, you don't want me there. You don't want me to. Well, one of my friends, best friends, Sam Storch, who for many years was a member of the Astronomical Society, still a member of the Astronomical Society of Long Island. Now he lives in Florida. He used to refer regularly to the Rayo curse, and so he says you don't want Joe Rayo to go to Cherry Springs if you've been planning to go to the Black Forest Star Party or whatever. You don't want him to go, and they're certainly right. I'll stay here by my lonesome. So the only person who gets disappointed is me, not you.
One last question?
Joe, do you still read the New York Times? You don't have to answer.
I was a columnist. I was a columnist for the New York Times for 15 years, I might add. In 1983, Kenneth Franklin, who was the chief astronomer at the Hayden Planetarium, co-discoverer of the radio missions from Jupiter, was asked by the New York Times to write a column which appeared every Sunday on the weather page in the Times, had a star map and a 300-word dissertation about what was coming up in the upcoming week for you to look up into the nighttime sky. He did that for 15 years, and then after that, he told the Times, I'm retiring. I don't want to do this anymore. And the Times said, oh, well, what are we going to do now? He said, well, if I may make a suggestion, and he made the suggestion that this person here take over the column, which I did, and I continued to write it for another 15 years until 2013, when the Times said, we're doing some cutbacks, and one of the things we're cutting back on are some of the little features, and they cut back, and that column went the way of the world. So I wish I was still doing it, but and it was fun doing it every week. But yeah, I even did a couple of stories for the Times as well. So there you go.
Joe, thank you so much for, again, an informative, exciting, and engaging program. Some of us certainly are looking forward to following through on those recommended observations. And we hope to see you back here in the not too distant future. So
Be back with you again in January for the talk I was going to give tomorrow if I had been there in person. Adventures of an Eclipse Chaser. Over the last 50 years, I have been to 14 total eclipses of the sun, and I've had an interesting event or an interesting sidelight to each one of those events. And I'll be back in January and tell you a little story, 14 different anecdotes about each one of those eclipses. And I look forward to coming back and saying hello to all of you once again.
Thank you.
Thank you.